Everyone. I can't believe that we are in episode number 11 and we have done chapter 4. Well, we're going to finish chapter 4 today and we will start chapter 5. So, chapter 4, as you know, is about screens, and chapter 5 is about horizontal and vertical scroll on the Amiga. Also, I'd like to thank, of course, and the man himself, Fabio Ciucci, I'd like to thank Fabio Ciucci for letting me doing this stream about his book, basically letting me stream his book, which is quite an honor in a way. For sure, I did not expect to do such a thing, and yeah, here I am in episode number 11. Okay, so let's start with the book, continue where we left. If you recall, last week, the example for A, which I have highlighted here, okay, we did at this, let's say we followed the code. The code didn't show anything on the screen, but we needed to understand the routine. And the routine was how we assign, we not assign, we update the bit plane pointers in our copy list, which is quite an important routine because this is something that you will be using often, and it is something that you will do quite a lot. Okay, for each image you will have to assign the pointers basically. So yeah, you'll be constantly doing that, and hence the routine is quite an important one. So let's continue. So during my time, okay, when I was coding for the Amiga, about 30 years ago, I didn't care much about compatibility because what I really knew was the Amiga 500, and to be honest, in 87, 88, 89, 90, there wasn't anything else except the Amiga 500. Then the A500 Plus came out, I think in 1989 or 90, and then in 91 or 2, I think 91, the A600 came out. So till then, you only cared about the code runs on an A500, so you didn't need to think about having to insert code to make it compatible with an A1000 for the AGA chipset, because the AGA chipset did not exist and nobody knew. So now Fabio is going to talk about the commands that we need to add for compatibility, so that our code works on any machine. The first two are, we moved 0 into DFF1FC, which is disable the AGA. Basically, it's the register which is called F mode. Then we move C00 in DFF106, which is BPL-con3, which is also disactivates the AGA mode. I mean, to be honest, this one is not really deactivated, but we are just making sure that it is with that value, basically. Then what we need, and this you need it also to do it on the A500, to be honest, this code. So when you are not using sprites, you will still need to initialize the pointers of the sprites. As you see, the mouse pointer sometimes causing some jittering on the screen. So basically this code is we are initializing the sprite pointers. Each sprite takes 2 pointers, so 1 to 0 and 1 to 2, and we have 8 sprites, so there are 16 of them. They are all with 0, as you see, and like that, these sprite pointers, the sprites will not create any issues, let's put it this way. We discussed the sprite pointers, so now after, basically there isn't much. We just initialize them to 0 and that is it. I do not have any more notes in relation to this. I just mentioned everything. So we can go and do example 4b. Okay. Let's do example 4b. Actually, I already loaded it, assemble it, and now we're going to see an image. Okay, there you go. That is our image. Please note, the original image, as I explained from the book, did not get transferred properly. You're also seeing the flicker from the sprites. That is intentional. I will show you in a minute by adding the sprite, what the sprite pointers will do. So I just converted an image quickly, let's put it this way, and I'm using that image. It was a 3-bit plain image, and I'm using that. The colors, I will update them later on. I just left it with the original colors of the image that the book had, just to make you aware of what really happened. One of the exercises that I asked you to do last week is to create an image yourself using either KEFCON or the AGA to IFF. I don't know how many of you did that, but for sure you need such an image if you want to do the examples in the book, because of the issue that they used asterisks in file names, and on Windows when they transfer them, that file name did not get transferred. There are others with that issue. So if I go to here, so these sprite pointers are remarked. Okay, is it the right place? Hold on. No, it's not the right place. Sorry. So let's put this how it was, and we go further up. Here. So if I enable the sprite pointers now and make them 0, now you will see that we will not have any more that flicker on the screen that we had before. It was there just to show you. I did it. The book displays them immediately. I did it so that I show you exactly what happens when you leave the sprite pointers out. So that is why I showed it with them remarked basically. Now the code. Let's go to the book. And we need to be into the other one here. Now the code is the same code that so here we initialize, okay, the normal thing. We initialize, we kill the OS, okay, and here is the routine that we did, which was example 4a, okay, that we did where we update the sprite pointers, okay. So nothing changed. This book is always is built up in everything is done step by step, and we built like blocks on top of the previous one. So basically we took what was in 4a and we edited that code into our normal display routine, into our what we previously had for the copper. So here we set up the bitplane pointers, then we initialize the copper, okay, then we do the compatibility registers, okay, like what I discussed before, so that we are compatible with AGA. Then we have our routine that waits for the left mouse button, okay, and then we exit the system. Now I know that you do not understand Italian, okay, I mean, unless you use Google Translate, but the code, you should be able to follow it, you should be able to understand it. I covered everything there, so it's not that I'm talking it's not that I mean, all at the end, what you need to understand is the code. The rest, the text, I'm explaining it. So I do not waste too much time in explaining what he's saying in text. I actually always focus uh, my way of showing you by focusing on the examples more than on what the book says. Sometimes I have to cover what the book says in terms of text, but I also concentrate on the diagrams then more than anything, because I know that as English you will not understand the Italian that you have in the book. And so I hope you appreciate, in the sense, what I mean, not appreciate, but that's not the right word, that you understand what I'm trying to do, because I mean, you do not need to look at the book, you need to look at the examples and check the examples. Okay, so the routine does one thing, okay? As I said, update up this routine, this blue part of the code. So the routine does, so here is the sprite. So I explained the code. Now I'm going to explain the copy list. I'm going to do this once because the book uses always the same copy list, the same routine everywhere. So I just do it with the first example. Well, in this case, this is the second example, because the first example was just to show you the routine. So this copy list has got to 0 as the sprite pointers. Okay, this is the init default values to display a screen, which in chapter 5 we will be going through them. Here, this is the we are telling the bit plane pointers how many we have. In this case is 3, as you can see here, 1 and 1, and this is the bit that has always to be on for compatibility. These are the bit plane pointers which the routine is using to update. So we have a 3-bit plane, so we are putting the values here, and here we are initializing the color, and that's the end of our copy list. And this is the image that we are including into the file so that we display it, basically. So not much, nothing special. As you see here, he talks about doing comments into the code, and you will see the sprite pointer creating some flicker, but I already showed you that, so I will skip this part, but this is what we did. So here I'm going to execute show example 4b1 and 4b2, and I'm going to show you the difference between one and the other one. So this was another let's say example that he so as you see, as I said, guys, ignore the image colors for now, okay? The image colors will come at a later date. As you see, just by adding a small copy list, okay, the image is more, let's say, pleasant now to the eyes. It's more nice to see, to look at. So that's one thing he did, and what he did is he just added a copy list here. Look, he added this copy list, okay, at the end of the previous of all the copy lists that I discussed. So he added all this, and this creates that effect of blue. I mean, you can see we are waiting for a certain position on the screen, and we change the color, the foreground, the background color, which is color 180, okay, to shades of blue. You can see it here. It's all taking the shades of blue color. So that's one. And this one. So here I added the shades of yellow to the logo. Okay, this is to make it a bit more pleasant. And what I did is just replaced the colors that were in the book for the original image with shades of yellow. Okay, where is it? Yeah. Okay, you can see these are all shades of yellow, um, instead of the gray ones that he had, because they did not match this image. Unfortunately, I didn't go into the detail of finding the best image that I could. Also because I needed to look for an image that has got two sections in it. Because in future, okay, in future articles, sorry, not articles, in future examples, okay, the image will be split. So you will, before the original image, from what I understood, had the word Commodore on top, and under it that was the word Amiga. While although I didn't find such an image, okay, mine has got Amiga and Amiga, and just the logos, the logos of the Amiga differentiate one from the other, and of course the old and the new version next to each on top of each other. But you will see, for example, in future, the top one scrolling to the left, and the other one scrolling to the right, and things like that. So this is why I needed an image with such things, and also the rest had to be um, blank, basically. I could not have an image with a background of something, because other things will happen behind the image. So I tried to find something. So it took me some time to find the right image. So then, finding the right image, I couldn't waste more time trying to find with the right colors also. So I just left it as is. But it still does the job, and I think it is acceptable as it is. So that's basically it for 4B. Let's see if I have any notes in relation to 4B that I need to mention. You see the copy list is down here that we added. So that is all. Here is, yeah, here he's saying only programming in assembler it is possible to take full advantage of the copper and to do what you like with it, which is true. Only with the assembler you're able to manipulate the way you like. When you're writing a game and a game has got many colors, okay, on the screen, it is because, remember, we only have 32 colors in theory, but it's because we are manipulating the copper that we are able to have so many colors on the screen. And that is one of the strongest point of the Amiga, or at that time it was for sure the strongest point. And to be honest, I still consider it one of the strongest points. Um, Although I have to say the PC has got its strongest points also, but I am not able to program a PC using graphics. I remember I tried, and Interrupt 13 uh, became on my nerves, and I said, okay, that's it. And I stopped. So, yeah, it's I did not enjoy programming the PC, because I did learn 8086 or 80 or 80286, 80386 when I tried, actually. 286 and 386. I never tried to code them when it was 486, but 286 and 386 I did. I wrote some, I think some DOS game, that uses the text text screen of DOS, that ran in DOS basically, but where's the fun? I did not enjoy it at all. It didn't have sprites at the time and all that crap, so, and copper, and so there was no fun in it. And but some people still like doing that, so yeah. Anyway, so that's what he says. Let's continue with the book. Okay, so we actually need to do also for C. So let's do for C. So there you go. You see why I needed such an image, because um, of what it does. So if you recall, all the copper bars that you see, that you are seeing right now, okay, are from chapter 3. We use them. We created these copper bars in chapter 3. So all the code, all the movement that we have there was explained in chapter 3, when we were doing copper, we were manipulating the copper. So there is no real code to explain in this, from that sense. Okay, but I'm going to look for from through my notes to see if he mentions some other things that I need to mention. But the code, you already seen it. You already seen the code to display an image. So he just merged both codes. I think it was 3H or 3F and H. I cannot remember exactly the examples, but he merged those examples all together with 4B, because now we are in 4C. As I said, everything is building blocks, and that's what he did. So let me see what the book says. Come on, yeah. Okay, so I think yeah, enable scrolling. So here, what did I write? So yeah, everything the same like the previous example, but he added the routines from the examples in chapter 3, which are here. You see, these are the same routines that there are in those chapters, basically. So that is all. Um, let's see what else I changed or I noted. So this code, you know it. I already explained it, so I do not need to explain anything. Um, okay, so here he says, look, look, I told you it's 3H, 3F, and 3E. These are from where he took the code and merged it with the code that we did in 4B. So it's the same code, 3 routines, doing the same thing from previous chapter added to this one. So not much to say. Uh, let's see if there is more to this example. Uh, so I think there's another one though. Let me see. I think for C there is, for C1, yeah. And I think this is something that I added. So I'm trying to remember what I changed in this. Uh, to be fair, I think it's the same. Uh, I did it to test. This is just a test. So I didn't do anything. So it's the same example as previous. I was, when you copy and paste, I was afraid I was going to overwrite, because this is actually an example. You need to do it. I was going to change things, and yeah. So actually, I didn't. I'm sorry, I just still checking, but yeah, I didn't. Let's see. So this is with Amiga. Did I, for example, do the other with a different logo? No, it's the same. No, so there's nothing. There is no more in relation to this chapter. Um, we haven't yet finished the chapter. He talks about other stuff, but in terms of examples, I believe we did. So what he says here is, okay, so now, okay, so I gave you homework last week to create images. As I said, I do not know how many of you did it. I expect nobody did it, but it's fine. I do, for your information, okay, I do all the exercises and all the topics that there are in the exercise book. I do them all, okay, so that we do not have to go. So if you go, if you watch these videos, you'll able to follow and follow the book properly, because the book will tell you. I mean, of course, for you guys that understands only English, you will not be reading the book, but for the Italian part, they will be reading the book and they will try to do the exercise. So I just show you that. But there are exercises also on the textbook, not the one with the where he tells you, for example, here to create an image with 3 colors also, and so this is the same type of exercise that I just gave you to create an image with raw, with, sorry, not 3 colors, with 8 colors, so 3-bit planes. Then and he starts explaining the IFF converter, KEFCON, which I remind you to use also the AGA IFF tool, which is, I think, a better tool. Just for your info, okay, I bought a tool called Promotion, okay. I can actually show it to you, okay. This is the tool that I use for graphics for the Amiga, and I actually bought the license. I mean, I do have it. It doesn't cost much, about 30, I think, $30 or something like that. Let me find it. Promotion. There you go. This is Promotion. Okay. So what it does, it's a PC software. It's a piece of PC software that somebody from the Amiga community wrote, okay, and wrote it with the Amiga in mind. Okay, let's arrange windows so that you see it properly. So it has features in it that it's easy to convert an image to Amiga format. So if you are using Photoshop, which I started not to like anymore, because of what Adobe is doing with all its spam, let's put it this way. But what I mean is, you can also use Promotion, but let's say you like to use Photoshop, then you load it in Promotion, and it has features to reduce colors, and literally the software talks about colors in index format like the Amiga does. Okay, so if you have a 256 image, you can reduce it to 8 colors easily. Okay, the software has got these features. Of course, it's a drawing package, so it is like Photoshop, not to the level of Photoshop, but it's more than enough. It's with the intention of pixel art. Okay, so it's more than enough for the Amiga, and it's also support animation and brushes and all that stuff. And I think the free version is everything except animation. So basically, I suggest that you download it and you use it. Then what you do, it supports to save as. I need to load an image first. Let's see if I'm able to load an image. For some reason it is not responding. If you're used to the PC and you are not like us, that you are used to the T-Paint, you can use something like this. And anyway, this was written, Ozan, this was written by one of the demo coders for the Amiga. So it is really with the intention of doing images on PC to convert them for the Amiga. You will still need to use dpaint. You will still need to use personal paint. So don't think that just by using this tool you are done. It saves in IFF. It doesn't save in RAW, at least so far. Eventually it will save in RAW. I was told by the author it will save, because he's a very famous demo coder. I was in touch with him this week, so I just don't want to reveal his name, that's all. But yeah, for some reason it doesn't want, it's not responding because the stream sorry, it is actually responding. I just didn't realize. Here is the window. Let's try to load an image. Actually, give me a second. Because I have so okay, I'm going to open something that you will be surprised. So I opened a normal image on you will see what it is in a minute. A normal image, and I'm going to tell it I want it to be 16 colors. Okay, so this is a normal PC image, okay, done taken with a camera. Okay, so I'm going to tell it I want it 16 colors and optimize the palette, okay, and to the nearest color. So when it loads it, it's going to do that already. Okay, and let's zoom a bit out. This is, okay, the bottle. You know, this is a famous drink in Italy, or was a famous drink, the bottle. And the 10, at that time when we formed Phase 101, okay, we were 5, and there was this, let's say, popular advert 101 that had a particular song, and in our mouth we were saying this this song, you know, 100 bollicine e una stella. And because we were repeating that, and 101 is 5, and Phase 101 was 5 people when we started, okay, we decided to name to use 101 because of that also. So we were 5, 101, and also because of the drink, which, to be honest, this drink, because we didn't have it I'm original Maltese, we didn't have it in Malta, but somebody sent it to me. Somebody sent it through post, send me this bottle. Somebody from Italy, a good friend of mine, and yeah, and when after I drank it, I used it as a pencil holder, and as you can see, it reduced the palette, okay, to 16 colors from an image that was, I don't know how many colors, but you know, taken with a camera. So that's one of its features that is very good. The other thing is that it saves as so I lost it because everything is black. So when you tell it to save image, okay, is it showing me the window somewhere else now? Because again, I need to tell it to arrange windows. This program is not finished, okay, so save image, save images. Let's do that. So it opened another window, okay, and look what it has. It has IFF as Amiga IFF animation, and LBM as the looks paint image. So it's easy to get a PC image and convert it into for the Amiga. You still need to use dpaint, as Ozan said. You still need to use dpaint or personal paint to do some things to it, but the most part it's done. The other thing is that you need to convert it into RAW, and as I said, I suggested last week. Yes, you can swap colors, you can do lots of things, and it is Ozzy. It's here. It's one of these. So I'm just trying to remember which one it is. But you can swap colors. You can do lots of things with it. Let me see if I manage to find it, because now I scrambled my own layout to show you this tool. Anyway, I think it's, yeah, copy colors when dragging. This one, swap colors when dragging. So basically you can swap a color one to the other and whatever you want. So it does that. So yeah, that is promotion. Of course, like somebody like Ozan will not be using such a tool, and I have to say I use it because many times when somebody gives me something, it's PC format. Now it's, you know, JPEG or PNG on all that crap, and although the Amiga you can have those, they are, when you are processing them, they are slow. So I prefer to have them as reduce the image and have it already as an index file, IFF, etc., and then manipulate it on the Amiga, because it's a lot faster than having a JPEG and manipulating a JPEG on the Amiga. That's the main reason, one of the main reasons why I use this tool. I just decided to buy it because I think it's great what they did. It's a very good tool. That's basically it. So here he's explaining the IFF converter, or the KEFCON, but as I said, I suggest that you use the AGA IFF converter. Anyway, let's continue. So he explains the KEFCON converter. Then I did not go into I did not write any, but I'm going to mention them. Here he's explaining inc bin. That means you include a binary file, which is our image file, into our source. As you noted, do not use asterisks in file names. Okay, well, on if you are in emulation, you will not be allowed on Windows, but do not use it in avoid it. And also try to name file names. Give the name of the file name, put the image dimensions, because you will not, if it's wrong, you will not know how many colors and how many bit planes it have. So here he's explaining InkBin, which I explained already several times. Then he's explaining that if you change the number of bit planes, so if let's say you have a 16 color one, or 4 bit plane, or if you have a 32 color one, which is 5 bit plane, then you need to modify this parameter, okay, in the routine where you say the number of bit planes. So here he put 4, so it is 5 in theory, because it's 4 to 0, so that is 5. Okay, so you can do also 5 minus 1. It is make more sense in a way in the code. And then of course you need to add the bit plane pointers, because if you add 2 more, then you need to add the bit plane pointers to that. That's how your code will change. but nothing else. And of course, you need to update BPL con 0 with the number of bit planes that you have. Nothing else. So that is what changes to have an image, that routine, because basically it's always the same routine to display an image. It's always the same routine to do it. You just change the number of bit planes to it. So now, so he gave you one exercise, that is to create an image of 16 colors or 32 colors. Then he gives you another exercise, and he wants you to create a half bright image that is 64 colors. Um, I'm I'm reading your message, Josie. My workflow is this: I put the IF file in a project folder, then in the make file I write a target file, image.raw, image IFF. Okay, and optionally you can add -p for palette. Okay, yeah. I mean, simple converter. Yeah, it's more than enough for most of the things. So yeah, I agree. You don't need much to do that. So yeah. So he's suggesting to write use the same code, but this time using half bright, that is 64 colors on the screen, or hem, that is 4096 colors on the screen. So basically you have an image which is 4096 colors. And he's telling you what you need to change. Yeah, it is portable. Yeah, if it's like that, it will be portable on Amigas. Yeah. So if you're doing half bright or hem, it's 6-bit planes now. So basically you need to add another bit plane pointer, okay, for the 6-bit plane, change from 4 to 5, okay, and of course enable the bit planes to make them 6, and also enable the hem. In this case this is hem, and in this case this is half bright. Where is it? The half bright is here actually. It's this bit, right? So this is hem. Sorry, half bright, you don't have another bit. Half bright is making it 6-bit planes. So sorry, I was going to confuse you. But yeah, 6-bit planes without hem enabled is half bright. With hem enabled, of course, 6-bit planes is hem 496 colors. That is all. This is an exercise that he gave you if you want to do it. And we came to the end of chapter 4, and we're going to start chapter 5. Chapter 5, as I said, talks about horizontal and vertical scroll. I'm going to cover horizontal scroll and finish there. Vertical scroll, I don't. Even if I try today, I do not have enough time to explain vertical scroll. The part of vertical scroll is quite long, while the horizontal is short for some reason. So we're going to start chapter 5. Welcome to the world of scrolling on the Amiga. Now, the Amiga uses two methods for horizontal and vertical scroll. The horizontal scroll is similar to the Commodore 64 version, but the vertical scroll is completely different than what you might know about vertical scroll on the Commodore 64. So I'm going to explain the horizontal scroll. On the Commodore 64, you have a shift of 8 pixels, or from 0 to 7. Okay, on the on the Amiga, instead of 8, you have 16 from 0 to um, is already on from 0 to 15, so that makes it 16 pixel shift. Okay, so that is how we anyway, so for scrolling horizontally, there is a register which is DFF102, which is called BPL con 1. Okay, to be fair, this register is very easy to understand. The high byte, okay, from 8, remember they are always 16, from 8 to 15 is not used, so that is always at 0. I was saying that BPL con 1, you have 8 bits, the lower 8 bits, that you can specify to scroll the screen. Now, this is divided in two, okay? So the first nibble, 0 to 3, okay? And the second nibble, which is from 4 to 7. Remember, in the last chapter, I mentioned that there are the odd bit planes and the even bit planes. So in theory, you can scroll either the odd bit planes or the even bit planes separately or all together. So this is why we have this register like this. So here, the first nibble, we specify the odd bit planes, and from 4 to 7 we specify the even bit planes. Okay, and further down, okay, he explains it in here. I do not like the fact that he used X and Y. It can be misleading, the X and Y. I would have used A and B. But the first nibble, which is X, is for even bit planes, as you can see, and the first nibble, which is Y, okay, so even these should have been swapped, is for the odd bit planes, and the X one is for the Y bit, oh god, for the even bit planes. So the rest, as you can see, is 0. Here are examples of types of scroll that we will have. Okay, so if you have 0, okay, if 102, remember DF BPL con 1 is 102, is 0 0, then we are scrolling nothing, neither the even neither the odd nor the even bit planes. Okay, so everything is stand still. If we put 1 1, okay, then we are scrolling both odd and even, and we shift them by 1 pixel. Okay, here is the same thing, but we shift them by 5 pixels. Okay, FF, we shift them by 15 pixels. Okay, so that's how to say, if we are shifting the screen together. Now here we are shifting only, remember it's only the X, okay, where the 3 is X. We are shifting only the even bit planes by 3 pixels. Here we are shifting, now here is a mistake on the book, okay. What he wrote on this side is he's saying that we are shifting the even bit planes by 12 pixels, but in theory he's saying we're shifting the odd bit planes by 12 pixels. So this should have been 0B. Okay, so that's a typo in the book. And here we are moving the bit planes. So the even we are moving them by 3, and the odd we are moving them by 14. This is how you create parallax like Shadow of the Beast, having 2 bit planes and scrolling one faster than the other. That's what the Amiga can do automatically using the hardware. Okay, that's basically it to scrolling horizontally. So there isn't much. You just scroll this register, you just scroll the values, increment the values of these, and when you reach 15, then you reset to 0. But before you do that, you shift the screen, which he is not explaining here. So now we arrive into example 5a. So let's read example 5a. Assemble it, and there you go. We are moving an image left and right, okay, by 16 pixels. This is all he's doing. We are not continuing shifting, basically, as Ozzy would suggest, but we are shifting from 0 to 15, and then we go back. The routine, okay, because the routine is a very simple routine. Trust me. It's a routine that you've seen several times. Let's go in the book. Which we did for, let's say, for moving the copper bar left and right. Instead, we are updating the register. So it's always the same. So I'm just going to explain the whole routine. Explain it, but just go through it because it's the first example. So I always go through the first example to remind you. So here is our standard routine. That is to kill the system. Here is our routine to update the bit planes for displaying the image, so that it can display the image. Here is the initialization to the copper and having compatibility, okay? All that we are compatible with AGA, basically. Then we wait for the mouse pointer. Okay, wait for the vertical. Wait for a particular position on the screen before we call our routine, and then of course we continue waiting till if we press the mouse we exit, okay, and we return to the OS. What he's doing, so this is our routine. This routine, you've seen it many times. The only difference is that he's doing subtraction and addition, okay, so these are the same, okay, but instead of using it on a copper bar, he's doing it on the register of the horizontal scroll. So there's not really anything to explain. It's if you take one direction, you know that there's a flag. If you reach the limit, we set the flag and we change direction. So it's not really, we've seen this type of loop several times, so we are just using the same code that we had before. Not really much to it. The only difference, as I said, is this, and this is why I put it in red, while this is the code that we are used to. Here he's moving both odd and even together, but he is going to show us that we can separate the odd and even. And if this is what we have, okay, in the code, he's telling us to change these 3 lines because we are updating these 3 lines, both odd and even, and to change them with where is it, 1 0 and F0 and 1 0, and this means that we are going to move them. We are moving the even bit planes. Okay, so that is example 5. A1. Okay, if you can see, and this color I changed it to white, it was yellow, but to show you better, okay, you can see that we are shifting bit plane 2 and not touching bit plane 1 and bit plane 3. Okay, that's all it is, just to show that we can move different bit planes. And of course there's the example the opposite way around, where we have 2 fixed and bit plane 1 and 3 moving. You can see it here. I left the color yellow this time because it didn't make sense to leave it white. And there you go, the image bit plane 2 stays fixed and 1 and 3 changes. Okay, so let me look at my notes. So I did that. Okay, I did this. I did this. And let me check here. Did I do? Yeah, I need to do 5B too. So now I need to do 5B. So what 5B does is a combination of routines. There you go. This is why I have the image that I told you. We are shifting top and bottom wording, let's put it this way, or our image, dividing it in two and shifting it and, you know, making the logo move a bit and having something moving on the screen. Hence why. So what he has done here, okay, I will show it in the code, but just to make you aware, he has weighted somewhere into the middle of the screen, okay, and then so he started shifting the image. When he arrives at a certain position in the screen, okay, he shifts the rest of the screen, so the bottom half, to a different direction, and like that they are moving opposite each other, okay, and they look like dancing or whatever you want to call it. So now the code is the same code that you saw to move an image when we were shifting it left and right, but he is just splitting this screen, so nothing changes, to be fair. So as you see, this is our routine to shift the screen, but he is waiting and then shift the screen the opposite way around. So we have the same routine copied twice and with a different direction. And here you see he is waiting at a particular address. So this is the init, so this is the first part and this is the second part. So when it initializes the copper, we are updating this register, the 102 register as always, and we are updating the value here and we move it to the left, okay, while when we arrive at this position of this on the screen 70, okay, we are moving it the opposite. So here you can see it started with 00, while here we started with FF, okay, and we decrement. So in here we see a sub, okay, and in here we see an add. No, anyway, Not to confuse you because I'm getting confused myself, but it's the same routine, just starting at a different location, just splitting it and scrolling at a different speed, not different speed, same speed, but opposite directions. So nothing really changed in terms of the routine. Just one is flag 2 and the other one is flag, and that holds where you are basically till you change direction. Nothing else. This you remember the copper bar which was red and white going up and down. It's using the same routine of that copper bar in chapter 3. So nothing really, nothing that we didn't cover. So I think we are close to the end of this stream today. Let me check my notes because I think now we start vertical scroll. I will finish here. Thank you very much and see you next week.